Okay, Assalamualaikum. Today I will explain example 62 from the fluid mechanics notes. The example use conservation laws, especially the linear momentum equation, to analyze how moving fluid exert force on the solid object. So our solid object is the elbow. So our objective is to determine the inlet gauge pressure and to calculate the force required to hold the elbow in place. So for the first step, we begin by selecting a fixed control volume around the elbow. Because the flow is steady and the fluid is incompressible, the mass flow rate entering and leaving the elbow must be the same. So we use mass flow rate in equal to mass flow rate out equal to 40 kilo. 40 kilo we get from this. To analyze momentum, we need velocity at the inlet and outlet. We use continuity equation. Velocity, mass flow rate, rho, and area. So for inlet, we get 1.24 meter per second, and for the outlet, we get 20 meter per second. This large increase in the velocity indicates a large change in momentum, which means a force will act on the elbow. Force will act at the elbow. Next, we find the inlet pressure. Because the pressure force contributes to the total force on the elbow, the outlet is open to the atmosphere, so P2 point gauge equal to 0. This one equal to 0. The outlet is also 1.3 meter higher than the inlet, so how we get the area is from this 30 cm convert to meter become 1.3 meter. So by solving the equation, we get 202 and 2 kilopascal. This pressure act on the inlet area and push on the elbow. Now we apply the linear momentum equation, resolving force into horizontal and vertical direction. In x direction, the force comes from the inlet pressure and the change in horizontal momentum as the water turns to the corner. So we get equation, we use this formula, and we can get minus 253 Newton. The negative sign means the fluid push to the elbow to the right. Push the elbow to the right. So the anchor must pull to the left. In z direction, the force comes from the upward momentum to exerting the upward momentum of the exerting water. So FRZ, we use this formula. So the last answer is 144 Newton. So the water changes both its speed and direction, so it exerts force on the elbow in multiple direction. To keep the elbow stationary, the support must apply equal and opposite force. So thank you. So for the example 64, water jet striking a moving kite. The goal is to determine the braking force required to keep the kite at a constant speed, to calculate the power associated with the force, and lastly to find the acceleration of the kite if the brake fails. So for the first step is we control volume and relative velocity. In this example, the control surface is moving. It's moving because the kite is also moving. Therefore, we must use relative velocity. For the formula is VR equal to velocity jet minus velocity kite. So we use this, and that we get 25 meter per second. This relative velocity determines how fast the water actually strikes the kite. Second, because the kite is moving away, not all the water leaving at the nozzle strike the kite is second. So this water at the nozzle not. So the effect we must calculate the effective mass flow rate, which is we use m flow rate equal to P rho VR. This adjust mass flow rate is used in the momentum equation. So this one we can get 21.43 kilo per second. So the third step, we now apply a linear momentum equation in the horizontal direction. After the impact better sideway, so the final horizontal velocity is 0. So the final is 0. The force is therefore force equal to mass flow rate 0 equal to velocity. This negative sign shows the force act opposite to the kite motion if the braking force required to maintain a constant speed. So we must get the power of the force. So the power of the force is associated with this force is given by P equal to F velocity kite. This represents the rate at which kinetic energy is transferred from the jet water to the kite. From this water jet to kite. Okay, so lastly we must find the acceleration if the brake fail. If the brake of the kite is failed. If the braking force is removed, the force exerted by the water becomes the net force of the kite. Using Newton's second law, A equal to Fm. As the kite accelerates, the relative velocity decreases. So the force and acceleration will gradually decrease. Both is decreased. This example shows how the relative motion affects the momentum and force when a jet strikes a moving object. So that's all for me. Thank you.